Hi friends, this is Ashutosh Mohanty. Now I am making this video upon the topic of different methods of inverter and frequency controlled supply. It can be written as variable voltage and variable frequency. So there are actually three methods by which we can obtain this kind of supply. Now let us see what these three methods are. In each and every method, I will consider that there is a fixed frequency alternating current supply. So we have a fixed frequency AC supply. Now here I will use a controlled rectifier. I hope my handwriting is visible enough because it is really not so much good writing on paper. I should be doing an animation out of it. I will do an animation in the next videos. So what I am trying to say is that we have a fixed frequency supply. Now using a controlled rectifier, I can obtain a variable DC voltage. As you know that a rectifier generally converts alternating current into direct current. So I can obtain a variable DC voltage. Okay. Now this DC voltage, when fed to a standard inverter, that is the inverter that are generally obtained in the market of many companies. So as we know that an inverter converts DC to AC. So from here, from variable DC voltage, I can get a variable AC voltage. And also the inverter, with the help of inverter, we can also control the frequency, like we have studied in the cycloconverters, right? There we can also convert it the frequency. So what we obtain is that a variable voltage is obtained from here and a variable frequency is obtained from here. So we have triple VF supply, the thing I was telling a little while ago. So this is fed to an induction motor. So you see that we have done this voltage control over here. And we have done a frequency control over in this block. As you have studied control system, these are actually the blocks, and these blocks represent circuits and chips that we know about, and this actually entirely makes system. I have not used any plus or minus sign determining polarity. You will be able to understand that very easily. These are actually blocks which represents various functions of the circuit. So I will represent this as a block. So our first method included a control rectifier and a standard inverter. The first method. Then comes our second method. As I said, I will be using a fixed frequency AC supply. So here also a fixed frequency AC supply. Now here I will use an ordinary rectifier rather than a control rectifier. An ordinary rectifier. So as usual, an AC is given, we'll always obtain a DC voltage. But this DC voltage is a fixed DC voltage. Now we have to convert this fixed DC voltage into a variable DC voltage in order to control the voltage. So now I will apply a chopper here. As you guys must be aware of this chopper kind of thing, this chopper is a stuff that generally converts a fixed DC voltage into a variable DC voltage. It actually acts like a switch. It turns on for some time, then turns off. then again turns off, on, and then again turns off. So it basically kinds of chops the constant DC voltage like a knife which chops vegetables. It's something analogous to that. So we obtain a variable DC voltage. Now here we again use a standard inverter which will help us with the frequency control. Then we feed it to the induction motor. So here we again obtain one triple V supply. Now you must be very much aware with the fact that this chopper is here for the voltage control. And this standard inverter is actually used for frequency control. So this is another method which is very rarely applied in the industry, but this is a very good method. We are using an ordinary rectifier, chopper, and a standard inverter. Then comes our third case: how to convert a fixed frequency supply into a variable voltage and variable frequency supply. Again, we take a fixed frequency AC supply, we'll feed it to an ordinary rectifier as usual. So there goes our ordinary rectifier. So from an ordinary rectifier we'll always obtain a fixed DC voltage. Okay, my handwriting is very rough, please forgive me for that. Now this fixed DC voltage had to be controlled or converted into a variable voltage and a variable frequency. Now a very good instrument is available in the market, which is PWM inverter. PWM inverter. Okay friends, the PWM means pulse width modulator. It is actually pulse width modulator. You can find many stuff of this PWM on the internet, and I will also try to make one video upon this PWM, because it's a very important feature in our present day market, and it is used across many fields, from ranging from robotics to power electronics, everywhere. So this PWM inverter actually converts this fixed DC voltage into a variable voltage and a variable frequency supply. So it is a kind of magic device that actually does the work of an chopper and an inverter. So then this triple VF supply is fed to an induction motor. So here we have only one component which does the voltage and frequency control. So we saw here there are three kinds of way in which we can obtain a triple VF supply. So here goes our different methods of inverter and frequency control. Now I would like to show you some practical observations that I have got from the experiment of a variable frequency method. Now this the objective of this observation chart is that from here we will like to see the trend of how the V by F control method really works. See, if you have followed my earlier video, there I have told that our voltage versus frequency graph looks like this. This black line is for the voltage, this blue line is for the torque, and this pencil draw is for the power. So here we have seen that the voltage will be constant after the rated frequency and the torque will be decreased after the rated frequency. So, and this V by F is a ratio. So here it's a observation chart for the entire thing. Let's see, at 50 Hz frequency we have a voltage of 398 and a ratio of close to 8. Our armature current is 1.4 and our speed, that is synchronous speed, is 1500 rpm. So as we decrease the frequency, our applied voltage decreases, but our V by F frequency is constant. It is approximately 8 and armature current remains a constant for a while and the speed decreases. So from here you see that this equation, that when the frequency is decreased, EMF is decreased to keep the entire thing constant. If the frequency was decreasing, the EMF was constant, then the flux would have increased, which would have led to high magnetizing loss and iron loss. I will explain that thing in another video. There is a very basic concept and a very good concept about that. So what I intended to show you is that the trend, this trend of frequency decreasing throughout the experiment, being decreased manually, the effect was that the voltage decreased and armature current nearly kept constant and the speed decreased. So this is how the actual trend for a practical experiment does work. Thank you.